have any questions in the comments, and we can go through literally kind of anything that you want to in this session rather than, you know, a specific past paper. We're going to go through just literally anything you might have a question on. So if it's a particular past paper question, I can look that up. If it's something else you want to ask about or want to practice, we can do that as well. Yeah, my weekend was great, thanks. How was your weekend? Just let me know if the sound is working as well. Not sure if that first bit got cut off actually, but anyway. Yeah, I don't know if it recorded that, but I was basically saying this session is just for any random questions you might have, whether that's a specific past paper question you want to go through, whether that's a specific topic you want to practice a bit more, anything you've got in particular, you can ask in the chat below. Hi Akram, welcome guys. Let me know if you've got any specific questions that you want to go through. As I said, today's just like a drop-in, so it's basically led by you. Is 10 days enough to jump 3 grades? Well, I mean, that's only one paper, right? You've got 3 papers. So obviously the first one being in about 10 days. I think you could jump 1 or 2 grades, but also you've then got enough time kind of after that. You've got quite a lot of time between the first paper and then the second one, haven't you? And the third, to also improve those, because it's going to be an average of all 3. So even if maybe paper 1 is still quite soon, you've still got quite a lot of time for paper 2 and paper 3. So yeah, I think if that's what you're going to be dedicated on working on, then yeah, I think you could probably do a lot in the next few weeks, definitely. If that answers your question, you know, if that's your one thing you're going to focus on mostly, then yeah, I think for all of the papers as an average, you could probably increase your grade by quite a lot. Perfect. You have a vector question. Okay, which one is it? Is it like from a past paper, or is it just a specific question you have? If it's a past paper, I can look it up and paste it on here. Yeah, if you send the link on the chat, I think it should work. I can have a look. So for the non-calculator exam, there are a few topics that I would suggest are more likely to be non-calculator, if that makes sense. And there's obviously some topics that are more likely to be calculator. There's not really a distinction as such, especially, I don't know if you're doing Edexcel. That's the one that I kind of know the best. But there's definitely a few topics that are kind of more likely or more repetitive in the past that come up on non-calculator. However, it could kind of almost be anything, really. That's the problem. It could be kind of anything. So for the first exam, it's quite hard because technically you've got anything of the syllabus that could come up. And then after the first exam, you can start narrowing it down for the second and third. But I do have videos that I will be doing for the non-calculator. Oh, just trying to have a look for it. For non-calculator specifically, which will be coming out this week. So it's not come out just yet, but this week I will have, I think, like just most common non-calculator topics. I'm creating an actual video on that, so you can have a look out for that if you want. Yeah, unfortunately, it's not a clear-cut distinction between non-calculator and calculator. Yeah, we can go through 3D Pythagoras as well. No, I haven't. We can't see any link. Oh, does it not? If you want, you can email it and I can have a look through there. My email is literally... Oh, I can have a look at Maths Genie. I can bring up the website if you want. Maths Genie, very bottom, grade 8, grade 9 vector proofs. Okay, we'll have a look at that and then we'll grab some 3D trig questions. Vectors proof, yeah. Which question number is it on the Maths Genie one? Like, is it a specific? It goes up to 7, 1 to 7. Geometric sequences, you said as well. Yeah, we can have a look at that. Oh, you just want to have a look at any of them. Okay. I don't think the Maths Genie ones are super hard. You could do one of each type because they basically split it into, some of them are saying find the value of k, and then the others are saying prove it's a straight line. So there's kind of 2 types of question. I'd assume they're quite similar other than that. 7 and 5 look hard. Yeah, okay, that's fine. Yeah, let's have a look at that and then we'll go through the rest of what everyone else is asking for. Yeah, because that's 5 marks, isn't it? The others I think are 4 marks, so that's at least something to tell us it might be a bit harder. Okay, this is just literally from Maths Genie. For anyone else who might want to have a look. Maths Genie. It's a really good website to practice if you're looking for specific past paper, well, not necessarily past paper questions, but specific topic questions. Maths Genie is a good one because you can look through a list of the syllabus and have a look, and they have videos as well. They have the solutions and such, so that's quite good if you're looking for specific topic revision. Okay, so here we've got OA is 5A, OB is 3B, which you can see they've drawn on already. C is the point such that O to C, and then C to A is 4 to 1. Okay, so it's on the OA line, isn't it? So 4 to 1, so I don't know, roughly here, you can just draw it. Roughly here. M is the midpoint of AB, so they've drawn that one on. And then D is a point such that OB to OD, so again back from O, is 3 to 4. Show that C, M, and D are on a straight line. So I'd probably draw a line. Again, you can annotate, your questions as much as you want. I would probably draw that line. If it's going to let me draw the line, that'd be great. Oh, sometimes it doesn't let me draw it. I'll try and draw it myself then. Okay, that's not too bad. Imagine that's a straight line, right? So proving that anything are on the same straight line is, the first part is proving that you need parallel lines. So you got to pick from, you see the 3 points, pick any 2 lines. So for example, it could be the whole line, C to D, it could be C to M, it could be M to D. There's like 3 lines there. You pick 2 of those, prove they're first of all parallel, so we have to find those vectors, right? One should be a multiple of the other. Okay, so I would probably choose maybe the whole line because I think that's easier, isn't it? So C to D, we'd have to come back down to O, so we'd have to figure out kind of how to split up this ratio first of all. So you see how it's 4 to 1, like this side was 4 parts of the ratio, that was 1 part, wasn't it? And then the whole thing adds up to 5A. So we're sharing out the ratio, obviously the ratio adds up to 5. So 5A, you don't even have to write this really for your exam, just showing you, divided by 5 obviously gives you 1A. So each part is 1A, but we want the side of 4 parts. So do you see how this would be 4A, and that would technically be A. Now, the other thing is we are going backwards down the line, so it would be minus, wouldn't it? So C to D would be negative 4A. I mean, you could also go a different direction, but I'm going to go this way, to O, and then O to B, which we know is 3B, but we also then need to know B to D, so that's that other ratio, but just be careful of this other ratio, right? Because it's not split the same way as the first one. They've done O to B, and then back from O to the whole way to D is 3 to 4. So technically, if this is 3 parts, that one there is 1 part, isn't it? Because it overlaps to a certain extent. So if that's 3B, then this would just be B, wouldn't it? That bit there. So plus another B. So overall, we've got minus 4A plus 4B. Now I would pick either C to M or M to D. Probably I would just stick with the same starting point. So C to M I'm going to choose. So how could we go C to M? You could either go the same kind of way to B and then back up, or you could obviously go up to A and then down halfway to M. It doesn't really matter which direction, whichever, makes more sense to you. C to M. So either way, I'm going along the AB line. So I would have to know AB as well, wouldn't I? That's kind of like an additional point. AB. I'm going to go up to A, down to M, so I'm going to do AB in that direction. So A to B would be minus 5A plus 3B. And then A to M is half, isn't it? Because it's the midpoint. So do you see how you could just multiply that by a half? Same exact line, it's just half the distance. So I'm going to go from C to A, which is just A in the correct direction, and then plus the half minus 5A plus 3B, again, correct direction. I would call this vectors geometry. That's what I would call it, because it's vectors, but it's not the column vectors. It's like the geometry, like the shapes one. I think you could sometimes call it vectors proof. I think on the Maths Genie website it's called vectors proof. If you're looking for the specific Maths Genie one, it's called vectors proof. I can drag it over here so you can see. this one here, right at the bottom, 8.10 vectors proof. That's the questions these are on if you're looking for that. But yeah, either vectors proof, vectors geometry, one of those names. So obviously I'm going to expand and simplify this. I don't know if you can still see that. Yeah, hopefully you should be able to still see that. So that would be minus, and then a half times 5. So you have to also be quite good with fractions here if it's a non-calculator exam, which it could be. So that would be 5 over 2. If you've got a whole number multiplied by a fraction, it only affects the numerator. So half of 5 is obviously 5 over 2. And then again, half of 3 is obviously 3 over 2. And then I would obviously add them again. So let's bring this over here. So we've got a plus 3 over 2. So that's like 1a plus 1.5. A, so that would be 2.5 or 5 over 2. Oh, wait. Make sure you add the right ones together. 1a minus 2.5, isn't it? So that'd be minus 1.5, which is 3 over 2. You can put decimals. I just like to use fractions. And then the b was just 3 over 2, wasn't it? Yeah, that's fine. Okay, so once you've found both of them, so for OA, yeah, so basically, yeah, you're right. It is 4/5 and 1/5, but that's not a vector. That is just like if you were to share out the line. So one, the left-hand side, O to C, is 4/5 of the whole line. And then the right-hand side, C to A, is 1/5 of the whole line. But I then used, you see how the whole line is 5a. So I kind of basically split the actual vector, which is 5a, into 4/5, which would be 4a, and then into 1/5, which would be just 1a. So I just kind of went a step further than that, if that makes sense. So it is 4/5 and 1/5, but then I applied those fractions to the whole vector, the whole line. Yeah, okay, perfect. So now that we've got both, you obviously just, as I said, find out any two vectors from that line, whichever two you prefer, and then we want to prove that they're parallel. Because we've got over here, do you see, can you see that bit? Yeah, just about see that bit there. Do you see how it's 1, this is like 1a, isn't it? Oh, I can never write a nice 1. 1a minus 5 over 2. Do you see how that would make negative 3 over 2, as in it's like 1 minus 2.5, isn't it, which is minus 1.5. I just left it as fractions. So it's just that I've simplified that basically. So now that we've got this, we want to prove first of all that they're parallel. Yeah, this is for year 11, yeah. Yep. We want to prove that they're parallel, so that means proving that one is a multiple of the other. So basically just find the scale factor, as in what do I multiply, for example, the a coordinates by the a coefficients by to get 4 and minus 4 and minus 3 over 2 should be the same scale factor that I could multiply the b coefficients. Yeah, if you prefer decimals, you can use decimals. That's also absolutely fine. It just depends, because if you end up with like 2/3 or something that recurs, which I know we don't have it here, but sometimes you might end up with a recurring one. Yeah, if you end up with a recurring one, then decimals is not so great because you want to have the exact number. But in this case, it would be fine either way. So I would probably just divide, let's see, it's kind of like what you can go whichever direction you want, to the big one, to the small one, or the small one to the big one. What's easier? Probably 3 over 2. I mean, you can basically see that it's, they're both the same. One's a negative, one's a positive, but 3 over 2 divided by 4, or the other way around. It's up to you. If this was calculator, obviously it wouldn't matter, you put it in the calculator. I'm not really sure with Maths Genie if they are or not, because vectors could be either, couldn't it? So I'm going to assume it's not. Dividing by 4 is the same as changing the denominator, so that would be like 3/8. And then, so that's for, let's say that's for the B ones. Obviously the A ones are the same, except both in negative. Obviously divide it the same way, right? Do you see how you get the same answer? 3/8. So this is then my conclusion. I would obviously normally write it below, but I haven't put any space there. So therefore, I would put, you can write the words, CD is a multiple of CM if you want. I prefer to just write it like this. So which way did we do it? So CM, I think I did it this way around. is equal to 3/8 of CD, isn't it? If you divided it the other way around, because 4 is, you see how 4 is the coefficient of this one here? You can divide it the other way around. If you want to do 4 divided by 3/2, you can do it that way around. That's fine. You can do it the opposite way around, but obviously then over here you'd have to write this the other way around. So therefore they're parallel. That just shows that they're multiples. You could write down the words CD, obviously take the bigger one. CD is a multiple of CM if you want. Now, that proves that they're parallel because they're multiples, right? Then they wanted us to prove it's a straight line though. So the more specific thing, they're not just two random vectors that happen to be parallel floating around. They actually do, we want to show that they actually do overlap. And this is really easy because you see how in my case I chose CD and CM. They will always have one letter in common. In this case, in my case, it's C, isn't it? You might have chosen a different combination, which means you'd have a different letter. That's fine. So then I would say something like share point C in common. Therefore, that makes them on a straight line, doesn't it? If they're parallel and then they start, in this case, start at the same point, they must be a straight line. So it's kind of those 2 points there. You want to prove it's parallel first. That's kind of the main thing. And then you just mention that they both happen to have the same letter. So therefore it's a straight line. But it's effectively just finding the two vectors in the first place. That's the main bulk of it. Just find the two vectors in the first place, show that they are multiples of each other by comparing both coefficients. So the coefficients of A should have the same multiplier as the coefficients of B, if that makes sense. So you see here I got 3/8 for both. And then therefore they're parallel because they're multiples, therefore a straight line because they have the same point in common. That's basically what you want to do for proving a straight line. And I feel like question 7 is similar. Yeah. Oh no, question 7 is saying, given that they're on a straight line, find BE. So slightly different. But yeah, I do think that proving they're parallel or proving that they're on a straight line is fairly straightforward in the sense that you just need to find the vectors and then mention those things. I don't know if you wanted to also go through question 7 still, or if you feel like this would kind of help with question 7 anyway. Yeah. Okay, we'll do question 7 and then we'll have a look at, I know someone's mentioned 3D trig. We can do a couple of questions, and then I know that other people have mentioned specific paper questions, which we can also do. So we will get to them, okay? All right, so another 5 marks for vectors. So they've labeled OA and OB. Oh, it's kind of a similar shape. So C is the point on OA such that OC, oh, it's the same thing, isn't it, basically? So, you know, roughly about here, I guess. What was that? C. D is the point such that AD to DB is 1 to 2, 1 to 2. That's not the vector, those two, they're just scale, right? So I'm just writing that there, but it's not a vector, okay? Those are just scales. You have to have letters for it to be vectors. Then they've got the line OB is extended to the point E, which we can see. Given that CDE are on the same straight line, find B to E. Let's see if it will let me draw a line again. Oh, now it's working for some reason. Okay, that's fine. Right. This is obviously not to scale, so I'm just going to draw the straight line and then match up. We'll put C over here. Okay, so in this case, we're just looking for a vector, literally just one vector. We're looking for this one. Obviously, you might have to find other vectors in order to find BE first, but that's fine. So BE, let's have a think. What could we do? We could go up to D and then down to E, which would mean, obviously I'm going to need to know AB at some point. So I'd probably start there, I guess. So AB, A to B is minus, because I'm going backwards, minus 5A, and then plus 2B, because that's the correct direction. Now, I wanted B to D, which is obviously backwards, but also in this ratio 1 to 2. So that ratio 1 to 2, if we're going to use fractions now, aren't we, to split it up, that would be 1 1/3, add them up to make the denominator. That one's 2/3. So I want the side of the 2, don't I? I want the bigger side, so I'm using 2/3. So that would be technically D to B if we were using this direction, right? You could obviously have worked out B to A in the other direction if you wanted. So you see how that's 2/3 of that line. So that's kind of that bit. I'm going to leave that there for now, and then at the end we'll add them all together. So then I want also D to E, don't I? D to E. That's, I'm assuming, the bit that's going to be possibly more complicated, I guess. We could work out C to D, couldn't we? That bit we could work out, the small bit. Let's do that. C to D. So splitting up the OA line is the same as the previous one, isn't it? 4 to 1, the total is 5A, so this side would be 4A, this side would be 1A. So I would obviously want to go up to A, down. So that would be A plus, and actually then we're using the other side of that ratio, aren't we? The 1/3 of A, B in the correct direction. So I'll leave the symbols as they are. So C to D, that's C to D. Let me expand all of that and simplify it. So that would be a minus, wouldn't it? Minus 5/3 A plus 2/3. This is the example where I probably wouldn't want to use decimals, just because of the thirds is always a recurring one. Yeah, exactly. I'm going to expand the brackets. DB I will expand later when we bring it all together. You could have expanded it right now if you wanted. I was going to expand it later, because technically I'm going to have to put a negative because it's the wrong direction, and then to have to expand it twice. So I'm just going to leave it for now, but you could expand it immediately if you wanted to. Okay, so technically this is 3/3 minus 5/3 would be negative 2/3, wouldn't it, for A, plus 2/3 B. Now this is the bit where we're going to use the logic of the fact that it's a straight line. We just said to prove a straight line you need to prove it's parallel and then that they have points in common. If you think about that in the reverse order, I guess, the logic here is that CD is obviously a small part of the whole line, so it's obviously some smaller version, isn't it? CE as a whole line is a multiple of this, if you think about it in the other way. So I guess we would want to figure that out. Yeah, it's a bit of an odd question, this one. So basically, I think what we have to look at is if you were to find CE, imagine that you were just going to find it in a normal way. What I would probably do is go down here to O, so like minus, the way that I would find it is I would do minus 4A, and then I would have to come all the way along here. And you see how that's obviously just B. We know that BE is some version of B, isn't it? 'Cause it's on that straight line. So it'd be like something plus, let's say just X for now, we don't know, plus something B, isn't it? How did I get minus 2/3? And not 4, have I got it wrong? Because this is technically 3/3, isn't it? If you were to put A as a whole one, no? And then do you see how if I subtract the numerators, it would be 3 minus 5, which is minus 2? Does that make sense? It was just, yeah, it was just because technically it was 1A, and if I make that into fractions, it was 3/3. Because obviously when you subtract fractions, you have the same. That was the only kind of thing that I kind of, yes, just skipped over it a bit. Yeah, just for that reason. You have to have the same denominator when you're subtracting or adding fractions. Yeah, that was the only reason. So, do you see how if I were to follow it in actually working it out, it would have to be minus 4A, and then it would have to be something B. Now, because now if I get my CD again, let me bring my CD so you can compare them. minus 2/3 A plus 2/3 B. These are on the same straight line. Obviously, CD is a smaller one, isn't it? CD is smaller than CE. But do you see how they must be multiples of each other? Now, if we actually know for certain the A coefficients, do you see how that means that we could work out the B coefficients, couldn't we? Because it must have the same, whatever you multiply the A's by, you must multiply the same by the B. Yeah? So, I mean, it's basically the same as the previous one, actually, isn't it? But either way, you can kind of look at it and go, well, that's 4 and 2/3. This one's also 2/3, so that one must be, do you see how X must be 4? I don't know if I've written that too far up. So a bit of an odd question, this one. I mean, it's quite hard to come up with geometric vectors questions, so it's a bit of an odd question. But do you see how that would have to be 4? Because it would have to be a multiple of the other one. It's kind of odd, really. It's kind of a difficult one to pick up on, I think. So that's the whole CE line. Now we've got to actually remember what we were trying to do in the first place, haven't we? So I was going up, I personally went up at B to D and then down here, so I need to know D to E. Most of vectors is just writing down different vectors, basically. That's most of the marks. So it's basically the difference between these, I guess, isn't it? Because we don't want the C to D bit. So that would be over 3. 12 over 3, 10/3? Have I got that right? I'm just finding the difference. Four minus 2/3, yeah, is 10/3. So this would be minus 10/3 A plus 10/3 B for D to E. Actually, there's an easier way. Why am I even doing it this way? You can do it this way. There's an easier way now that I'm thinking about it. We just said that B to E is another version of B. If this has to be 4B, then B to E is just 2B, isn't it? So actually, you don't even need the rest of that, now that we're looking at it. Yeah, it's just figuring it out as you go along. A lot of the time when it's just finding a specific vector, if that's just the question, find this specific vector, it's just figuring out as you go. The answer should be 2B because of, if that had to be 4B and I know that OB is already 2B, then the thing that's left is 2B, isn't it? So actually you don't even need to go and do DB and then so on. You can just skip ahead to that. But yeah, a bit of an odd question, this one, I think, because obviously they've written it themselves, I'm assuming. It's quite hard to write vectors questions, so this one's a bit random. The one previous is probably more consistent with what they might ask you, because it was proving it's a straight line. But yeah, this one's an odd one. Okay. I'm going to move on from vectors just to see what other people want to look through. I know someone said 3D trig. I don't know if that person is still here who wants to go through 3D trig. Oh, Ben Atkins. I don't know if you're still here if you want to go through 3D trig. If not, then I'll just keep going through the list. After that was geometric sequences for Akram. So let me know if you're still here and you still want to go through 3D trig. If not, then I'll move on. Yeah, we'll get to the one under the November 23 paper. I'm just trying to go in order of the comments, basically. Okay, I'm assuming we can go on to geometric sequences. If the other guy comes back, we can have a look at 3D trig again. So geometric sequences, just generally, I'm assuming. I had some questions on that. Find it. So geometric sequences, basically, the main, the key thing about it is that you multiply, right? The same number, but every time you multiply by the same number. This session will go on until roughly about another 45 minutes, maybe probably quarter to, what was that, 4:35, quarter to 6. Yeah, but I'll have another one tomorrow anyway. Oh, do you have a specific one? Oh, okay. November 2022. We can have a look at a specific one. November 2022. Let me see. I'll just bring that one up now. November 2022. Do you know which paper it was? Was it the non-calculator? I can have a look, but just to narrow it down. Question 23. Oh, hang on, that's the mark scheme. Okay, let's see, 23. Oh, yeah. Okay, there's a part A and a part B. Do you want both parts, or is it just one of them? They're two separate questions, aren't they? We can do both. Part B, yeah, I thought part B was more likely. Okay, yeah, this is fine. So 3 marks for part B. Right, so if anyone wants this, this is the, what did we say, November 2022? Paper 1, question 23. Okay, so the 4th term of a geometric sequence is 5 root 2 over 4. The 6th term of this sequence is 5 root 2 over 8. Given that the terms of the sequence are all positive, work out the first term. So there is actually kind of like a formula for this. You can do it without the formula, but the way that I was thinking was that normally geometric sequences are AR, n to the minus 1, and A is the starting number, which is the one they've asked for, right? So I guess we're looking for A, aren't we, in this case? We want to find A. And then R is what they call the common ratio. You know how I said every time you're going to multiply by the same number? That's the R. So we would have to find out the common ratio, I would assume. Now, they've said the 4th term and the 6th term, so obviously there's a gap between them. So you can set it up as an equation if you want. So n to the minus 1 is obviously, n to the power of n minus 1 is the term number, right? N is always the term number. So in that case, that's 4 minus 1. So that'd be 3, which is 5 root 2 over 4. And then if you create an equation for the second one, so effectively you could think about it as simultaneous equations if you want. That would be 5. Do you see how there's a difference of 2? Unfortunately, it's not just 1 difference. So what I did, and you can do it just by thinking of this logic, you don't necessarily have to write it like this, was I said, right, well, if I divide the two of them, do you see how that would leave me with the common ratio R, but squared? So you don't have to write it out like this. You could just divide them straight away and go, yeah, but I'm going to have 2 different. That's fine. I just like to lay it out so I can see what I'm doing. So I would probably divide them. I know that because that would get rid of the A's, which I know we want A, but we're going to have to find R, the common ratio, in order to find A anyway, so that's fine. So I would divide them, obviously divide the bigger by the smaller, so it's effectively simultaneous equation. So if I divide AR to the power of 5, so AR to the power of 5 divided by AR cubed, obviously you see how the A's would cancel and then you'd end up with R squared on that side, and then that would obviously be 5, I'll write it as keep flip change because this is fractions, isn't it? 5 root 2 divided by 8, keep flip change, so multiplied by 4 over 5 root 2. If I multiply that, do you see how like the 5 root 2's would just cancel? I wouldn't even need to multiply it, they just cancel. You end up with obviously 4 over 8, which is the same as a half. So that's R squared. Now obviously you just want to know R, because in order to find A, I need to divide by, let's say the first one, by R cubed. I've only got R squared. So I need to know R to the power of 1, wouldn't I? Which is the square root of a half, which I know this is non-calculator, but you could use surds in this case if you wanted. It's kind of annoying, but you can. So what I did with this one, just to make it, because obviously we don't know what the square root of a half is, right? They're not going to make you work that out as a number, is you can also root it like this. You can root the 2 separately, and you see how the numerator would just be 1, and then you get over root 2. That's the same thing. And then you could either leave it like this, or you could rationalize it if you really wanted to rationalize it. That's up to you, but either I think that looks a little bit better than the square root of a half. Anyway, so what we want is R cubed, don't we? For this first one to find A. So R cubed, let's say if I leave it, I could leave it like that, couldn't I? 1 over root 2 cubed. So that's 1 cubed, which is 1. And then you could always, I probably wouldn't use fractional indices. I would just maybe think about it as root 2 times root 2 times root 2. Do you see how the first two would cancel? That would become either root 4 or just 2, wouldn't it? So it's 2 root 2 there. Again, you could have rationalized it if you wanted to. And then if I divide, hang on, let me see if I can scroll down. Oh yeah, I can scroll down. That's fine. I could divide the first one by that, couldn't I? Because that would leave me with A, which is the first term. A represents the first term. So A, technically if you were to sub it in, but effectively we just want to divide, don't we? Divide across equals 5 root 2. Do you see how I'm now just going to divide across? So A is, again, it's keep flip change again. So we've got 5 root 2 over 4, and then divided by 1 over 2 root 2, or as I said, you might have rationalized it, that's fine. So keep flip change, 5 root 2 over 4 times 2 root 2 over 1, technically, right? I've flipped it. So then multiply straight across. That's 10 on the outside, and then technically root 4, but that, you know, that would cancel to become 2, wouldn't it? Over 4, so that's what, 20 over 4, which is, eventually you get to the answer of 5. Yeah. So you should get an answer of 5. You might have worked out differently to me, but either way, yeah, I might have gone a long route around it, but yeah, you might have figured it out kind of, let's say if you rationalized it or things like that. Either way, it's kind of this starting point. You can use this if you want, this formula. Where was it? AR n to the minus 1, well, or AR to the power of n minus 1 is what I'm trying to say. You can use that if that helps create at least a structure of what to do. So A is, that's the start, like the first term, right? Which, that's why I was trying to work out A in this case, because they asked for this, the first term, didn't they? That's the first term. R is what they call, you have to call it this, but technically they call it the common ratio. Now what that means is, you know, with a geometric sequence, you're multiplying by the same number every time. You're not adding, you're multiplying by the same number. So that's what you're multiplying by, and then it's the power of n minus 1. Now n is the term, isn't it? Term number. So like term number 4, as they said here, term number 6. Yeah. You can call this whatever you want to call it, but that's effectively what it is. The first term multiplied by the common ratio to the power of the term number minus 1 is basically the formula. However you want to write that is up to you, but that's effectively at least a structure that you could use if it comes up. For geometric sequences, you can apply that if you find that helpful. Okay, so that's the geometric sequences one. I'm just seeing what was next. Okay, someone has asked for Edexcel question 20, paper 1, 2023. Yeah, that's the one we'll do next. What was that? Question 20. I'm assuming it's June 2023, paper 1. Question, what was it? Question 20. Question 20 on the June one is functions. I don't know if that's the one you were talking about. November, yeah, I didn't think that was the right one. November. Paper 1. Okay. Question 20. It's a triangle one, right? With, like, obviously I'm assuming sine and cosine somehow. 4 marks. This is the one that I've got from November 2023. Yeah? Okay. This is November 2023. Question, well, paper 1, H obviously. So here is triangle ABC. Find the size of angle ABC. So that's obviously this angle here. You can call it X if you want. Okay, So when you've got obviously a triangle like this, initially it's not a right angle, but there's some sides. They've asked for an angle. It's obviously sine or cosine, right? That's the first thing. We're question 20. It's going to be sine or cosine rule. Then you've got to kind of figure out which one it fits into. It will normally only fit into one of those two formulas. So sine rule is normally two sides and two angles. Obviously that does include the one that you haven't calculated, right? The one that's missing. And then cosine rule is three sides and one angle. Again, including whichever you're trying to calculate. So in this case, you see how, for me, this is screaming cosine rule. So I'm thinking, right, this is cosine rule. Obviously, that's on your formula sheet, right? So you would grab your formula sheet, which I'll just write it here. Now, in the formula sheet, I'm pretty sure they write it like this with the side as the one that you want to find. Obviously, we're trying to find an angle, so we're going to have to rearrange it. Now, either you just memorize the formula rearranged for the angle, or you use this as your base and you rearrange it yourself. It depends how confident you are with rearranging. You don't want to get it obviously wrong. So you can rearrange it first, or you can sub the numbers in, then solve it. It doesn't really matter. Obviously, we're trying to find the angle, so you can relabel the angles, right? If they've labeled it wrong, because you see how cosine rule is based on angle A. So the angle that I want is here. So I'm going to label that A. You can relabel it. Therefore, the side A is obviously opposite. Now, B and C don't really matter as long as they are the sides that surround the angle. So we could leave that one as C, and then you could change that one to B, and then B if you want. But yeah, just make sure. Yeah, they're probably, yeah, I can have a look for one of those. So, would I rearrange it, or would I just, yeah, we could just, I don't know. You could rearrange it first, you could sub it in first, it doesn't really matter. I don't know what I would be inclined to do, to be honest. Rearranging it though, just so you know how to rearrange, I would add the whole 2bc cos A, because we want cos A to be positive, don't we? And then obviously subtract A squared. This is just to show you how to rearrange it, if you didn't know. It's really important we label it correctly, because obviously you're adding some, you're subtracting some others, and then divide by this. So you can just memorize this if you want, as in this formula, or you can rearrange it. Minus A squared. So that's the, if you want to find the angle, that's the formula. But now let's sub in some numbers. So B I put as 5. So 5 squared. C is 10 squared. And then minus A, which is 5 root 7 squared. Over 2bc, 2 times 5 times 10. You see how now you just basically have to work all of that out? Yeah, we're using cosine rule, yeah. Because it's got 3 sides, the sine rule wouldn't have fit. It wouldn't have, you wouldn't be able to use sine rule in this case. So 25 plus 100. When you square this, square the 5, square the root 7 separately, so that's like 25. Technically root 49, which is obviously then 7, isn't it? So you can just skip that bit if you want. So it's 25 times 7. Over 2 times 5, which is 10, times 10, which is 100. See how I'm just going to keep working through this, basically. Just keep working through it. So you've got 125 at the top. This one, you'd obviously just multiply. I'm pretty sure that's 175, though, if I'm not wrong. Yeah, 175 over 100, which gives you, just be careful, it's minus 50 over 100, which then simplifies to minus half. Now, this is the bit where, as you said, no, we don't square root the answer at the end just because we're not finding a side. You would if you were finding a side, because it's a squared, isn't it? But because we're finding the angle, there's nothing to square root. So negative a half. Now, this is the thing, because let's go back up. They want us to find angle ABC. What we've got here is not the angle ABC, it's cos of the angle, cosine of the angle. Yeah, if you had a calculator, you would, if you had a calculator, you would do cos inverse, wouldn't you? Cos to the power of minus 1. This is non-calculator, as you were saying. That's the kind of bit that you now need to link. So Obviously, there are certain values you're supposed to have memorized, not necessarily the negative one, right? Not necessarily the negative one, but the normal one. It's almost like the reverse of that. It's saying, well, what cos of what number, of what angle, is equal to a half? Yeah, you probably know that a half positively is 60 degrees. That's the one that you would more likely know. Now you can sketch out the graph. You're supposed to know the graph anyway, right? So the cos graph is like this. Starts at 1, obviously goes down to -1. So think about where minus a half would be. I know this is just rough. Minus a half is like here, isn't it? So we know that that point there is 90. You know that this point here is 180. So you can see that I'm focusing on this one. Do you see how that's between 90 and 180? So that's first thing. You know it's between 90 and 180. But the other thing is knowing that cos of a half, if you know that one, you should know, cos of a positive half is 60, isn't it? That's minus a half there. This one here is 60. So you can use that to help you figure out, do you see the distance between 60 and 90 should be the same on the other side. So that would be 90 plus another 30. Cos of half is 60, so you do. Yeah, that could also work. I was just thinking if you're going to look at the Akram suggested to look at this graph, you can see it's symmetrical in that case. So you should get 120. But you'd have to kind of make that conversion yourself. That's the bit that I think is difficult. Yeah, I don't tutor science, sorry guys, but I'm sure there's loads of people who do lives for science. Yeah. So yeah, you could, but the thing is, you should be able to get to this point, which I would assume is probably 4 out of 5 marks. I would assume, oh, was it 5? Oh, it's 4 marks, wasn't it? 3 out of 4 marks, I would assume, is this much. Even if you weren't able to then convert it into an actual value at the end, you've still got all of the rest of the marks. Okay, so that's that one. But yeah, it is hard to, I think it's more A-level logic, that bit at the end. That's the problem. It is a bit A-level, I would suggest. Okay, I'm just having a quick look. What next one we were asked for? Hang on. Okay, yeah, just talking about that question. I think if I'm not wrong, I think the next question was you were asked about, I was asked to do Sokotoa. Do you mean like right angle triangles? Yeah, Sokotoa I think is the next one. And then after that was the hexagon one. I don't know if you still want to go through the Sokotoa one. Yeah, we can do live streams the day before, that's fine. Yeah, I'm not sure about that. You still want to go through Sokotoa, or did you mean sine and cosine rule like this? Because that's obviously slightly different to Sokotoa. Sokotoa is like the lower level version of trig, isn't it? It's the easier version. With right angle triangles, sine and cosine is then this, which is harder. What was after that? It was the hexagon question. I feel like I'd missed one that was there. Maybe it was deleted. Yeah, we're just going in order. That's why I'm shouting out if anyone still wanted to go through these questions or not. You've said SOHCAHTOA is sine and cosine. Those obviously are like slightly different, so I don't know which of those you want, if any. If not, then I will move on to the next hexagon question. Okay, looks like we're moving on. Yeah, first class maths is also a really good resource. Actually, again, it's split into different categories, different topics. So that's also good, and they have videos on the answers as well. So that's also quite a good one. Okay, I think I know which hexagon one you're talking about, but I would need to find it. Like which paper it's on. Like I feel like I remember something about the area of a hexagon, but it's with trig, isn't it? Actually, I guess that combines the two topics together, so that's quite good. I don't know if you know which paper that one's on. Oh, paper 2. Yeah. June 2023, paper 2. June 2023, paper 2. Pretty sure that was a hard. I think actually I did that in one of my videos. It was a hard one. Let me just check if it's the same one. Oh no, this is a different one. Is this a different one? Oh, I was thinking of another hexagon one. Yeah, there's also this one, isn't there? Oh yeah, this is not a nice one, really. Okay. Let's copy that. Okay, this one. Yeah, you still have to split it up. I think I was thinking of a different one. Okay, this one you have to split up. So what have they said? Find, in terms of A, an expression for the area of the shaded shape. Obviously the shaded shape we don't have an actual formula for because it's like a really weird shape. So it's effectively what we'd call a compound shape, where it's made up of multiple different other shapes. So I would split it up. I think the easiest way to split it up is into, like if you draw horizontal and vertical lines, it becomes a square. In the middle bit becomes a square, and then there's kind of like these triangles that are identical. So four of these same exact triangles. So then all you need to do is work out the area of the square, and then just one triangle, and obviously times that triangle by 4. So it's effectively 2 shapes that we're working out. That's how I would, yeah, that's how I would split it. Okay. So let's see, what have they actually said? Identical regular octagons. Each octagon has side length A. Okay. So like A is here. A, so on. Okay, so we currently don't have the length or the width of the square, do we? No, this is paper 2 calculator, yeah. Paper 2. Well, either way, it's calculator. Yeah, so we don't have the length of the square, so we can't do that right now. I guess the triangles, though, we've got 2 sides. I mean, it's a nice isosceles triangle, isn't it? So what you could do if you wanted is you could use the formula for the area of a triangle, obviously not half base times height, but the other one, the trig one, from the formula sheet. Now, this is where you think about where are the angles. That's relating to the fact that they're regular octagons. So you could use the octagon to help you figure out some angles. Now, I'm not saying you necessarily memorize the angles in an octagon. Obviously, you probably don't know that off the top of your head. That's fine. There is a formula for polygons, as in any type of shape like this. N minus 2 times 180 will tell you the total degrees in any shape, obviously 2D. So in this case, 8 is the side lengths, right? The number of sides is 8. So you could work this out. This is actually calculated, so you might as well type it in the calculator. So the total of an octagon is 1080. Now, because it's regular, all of the angles, like this one, this one, this one, this one, they're all the same. So I can equally kind of divide this, can't I? If I divide the total by 8, then each angle is 135. Now that's obviously inside the octagon, but do you see how if I use those two as 135, I could work out the angle in the triangle at the top there. So you could do that if you wanted. So 180 minus 135 times 2 minus 180. Oh. No, not 180. I was thinking, why is that negative? 360, because it's around a point. I was thinking of exterior angles, which is 180. 360 minus 135 times 2 is 90. So that's 90. It looks like it, but I don't know if you can assume. That's 90 there. So you could use the trig area of a triangle, you know, the half AB sine C, which is on your formula sheet. You could use that. Obviously, we're inputting the letters as the side lengths, right? So then the area of the triangle would be a half times one side, which is A, times the other side, which is also A, times by the angle of, like, between it, which is 90. I'm pretty sure sine 90 is just 1, isn't it? As far as I'm aware. Yeah, sine 90 is 1, so that makes no difference. So the area of the triangle is a half A squared. Now, obviously, there's 4 of those. So just don't forget that there are 4. So then 4 triangles, obviously, would be 4 times a half A squared, which is 2A squared. So that's the triangle bit, right? But then you'd obviously want to know the square. Now, the problem with the square is this section here, isn't it? We know that there's A on the left, we know there's A on the right, but we don't have that length bit there. So I think there's different ways you could work it out. I think I would use cosine rule again from this triangle. Let me rub out this. Rub out that bit, because that bit's kind of in the way, isn't it? I would probably use maybe cosine rule. I don't know if there's an easier way to do it. Because we know the angle, we know the two sides, we're looking for a third side, which is opposite the angle that we know, isn't it? So that's what I'm thinking. I'm thinking we might use... Oh, you could use cosine rule. Actually, you could just use... Because this is a right angle triangle, you could just use Pythagoras, couldn't you? Yeah, exactly, you're right. You could just... Because it's 90 degrees, you could just use Pythagoras. I think you could probably use Tutor as well. I think there's a few different ways to do it, whichever kind of comes to your mind first. Obviously, as you said, Pythagoras, that would make more sense, wouldn't it? Be easier. So let's use Pythagoras for that. Obviously, this one that looks straight is technically the hypotenuse, isn't it? So you've got a squared plus a squared equals, well, I guess that one's c, isn't it? Let's call that one c. C squared, so that's 2a squared is equal to c squared, which is then, well, I guess if you were to square root it, you could just do root 2 and then a, couldn't you? So you see how this bit here is root 2a, and then so the whole side is a plus root 2a plus a, and then the other is the same because it is the exact same side, isn't it? If you've got a specific question about the start point, let me know. I don't have time to go through the whole thing again, but if there's something specific about the start that you weren't... Oh, there's the buzzer. If there's something specific about the start that you weren't sure about, then let me know if you have like a specific question about it. Okay, so now we know that, we can now just do the square. So the square side, so let me put this, the side of the square is a plus root 2a plus another a. So if we were to simplify that, that would be 2a plus root 2a, which if you wanted, you could put it as 2 plus root 2, couldn't you, if you wanted to. That's up to you. So then the area of the square is obviously both, well, just that times itself, isn't it? Or that squared. However you want to write it. You might prefer to write it originally as the other one, I guess, in this case, because we're going to square it. However you prefer to write it, doesn't really matter. Is that squared, isn't it? Now, obviously, they want something like this. So I'm thinking, let's, I guess, expand and simplify that. So it's double bracket, so you get 4a squared. I don't know if that's going to help. Is it going to help? Plus 2, well, technically 4 root 2 a plus, and then that would be 2a squared, wouldn't it? And then we would add it to this one down here. Oh, where's it gone? There. That one and that one. We'd add those together, wouldn't we? So total area, you've got 2a squared from the triangles plus 4a squared. Oh, yeah, I guess that would simplify, wouldn't it? 4 root 2a plus 2a squared. So what have we got here? That's 8. A squared plus 4 root 2a. Now, they just want us to factorize it, and this is where we find out if I have got it right or not, if it factorizes. So they've obviously... Have I factorized this right? Two a plus, yeah, that squared plus that other one, which was 4 times a, yeah, so that's fine. Oh yeah, this is meant to be a squared. That's why I'm thinking that it's not making sense. Make sure we expand it right. So see how we've got a squared in both, so you could pull out, I mean, you could write the answer straight as theirs, but you could pull out a squared, can't you? Because that's in both. And then what have they got in the brackets? Just a 2 and then just root 2. So they've pulled out 4, haven't they? There we go. Now that makes sense. So you just have to factorize it the way that they factorized it, basically. So they said where p is an integer, p in this case is 4. Yeah, you're right. P is 4, exactly. There you go. I think it's fine. It's more, maybe it's just more knowing how to split it. I guess that's the kind of thing that is the hard bit, is how to split it up. But yeah, because it's at the end of the paper, it could still be different versions of trig or Pythagoras, even with letters. You could still have that as a question. Technically, I guess you could have done this without a calculator. It wasn't really that difficult in terms of calculations. But yeah, that's that one. What was that? I think that was 5 marks, that one. I think this one was probably harder, yeah. I think this one was harder, for sure. Did we have a question after this hexagon question? Oh, someone mentioned about probability, wasn't it? Was there something before then? Yeah, I think the probability one was the next one. I don't know if that person is still here. Oh, you said congruent triangles, didn't you? Yeah, oh, you're still here for the probability. The n-1, was it like a probability tree one? Is that the one we're thinking? Let me open up my probability. I'm assuming this is for Edexcel, right? Because those are the questions that I have. Edexcel mostly. And then we can have a look at the congruent triangles, and then that's probably it. For today. Probability questions, right? Yeah, it was probability tree one. Yeah, you had to create like a massive equation, didn't you? I think with n and n-1 in the denominators and things like that. If not, then I'm pretty sure I made a video on it anyway. Like I think I've probably gone through that one in an actual video as well. So you can also have a look at that. But let me find it. Yeah, it's that one. I'm just trying to find which paper it was from. Hang on, so if it's in my video, I should have it shortlisted somewhere. Probability questions should be one. Uh, was the context green pens and blue pens? Was it that one? I might have used X instead of N, I guess, but it's the same thing. No, I'm just looking at which one it was. Was it the one with... I don't know if it was this one, because I think it doesn't say in the question, I don't think, the letter. It says it's pasted, but where has it pasted it? Is it this one with... I copy and paste it. Green pens and blue pens in the box. There are 3 more blue pens than green pens. Does that sound... Oh, it's counters. Not that one then. I mean, there's one with counters, red and green counters, but that one had 2 different letters. Like R and G. And then it said 2 more red counters and 3 more green counters are put into the box. There was that one. There was another one where it said the total... there is a total of Y counters in a box. There are X pink counters and 5 blue counters. I guess they're all kind of similar, aren't they? We could do the red and the pen one should be fine. I think it kind of makes the same situation in the end, like you're trying to create an equation, aren't you? Ultimately. Copy, let's see if it's going to paste it. I'm saying pasted, but it's not pasted, is it? Screen it. This is November 2018, paper 1. Okay, I'm going to have to upload the actual paper because it's not letting me paste it. Question 22. It was... I think it's this one. We'll see if this is the right one. Yeah. This is the one I was thinking of. It's the last question on the paper, so hopefully it should be helpful anyway. It's non-calculator too. Okay, so there are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box, and they've happened to mention that there are 12 pens in the box. So Simon is going to take at random... Oh, there's my alarm, sorry guys. Simon is going to take at random 2 pens from the box. And then they've given us the probability that Simon will take 2 pens of the same colour is 27 and 55. So that's our formula there. That's going to be our equation. Now, the thing with this is they've given us green and blue, but I don't want 2 letters, right? I only want 1 letter because I've only got enough information about 1 equation. So what I would do is in terms of green and blue, I would choose whichever one is obviously the smaller. So in this case, there's 3 more blue than green. So green is smaller. You could use N if you wanted. I normally use X, but if you want to use N, that's fine. X. So therefore, do you see how 3 more blue pens? Blue would be X plus 3. So that's what I would do because there's only information for 1 equation. I only want 1. So I would set up a tree just to visualize it. If you can do it without visualizing the tree, then that's great. Don't draw the tree, but I would draw a probability tree because he's taking 2 pens, right? So the first one, green, would be obviously then as a fraction, as a probability, x out of the total pens. Do you see how that would have to be 2x plus 3? And then blue would therefore be x plus 3 out of 2x plus 3. Now, that bit's fairly straightforward. The problem is then the next pen. So the next branches, because that's when you were saying about n minus 1. I think that's the logic that we're going to use here. You wouldn't even have to fill it all in if you don't want to. It's 2 pens of the same colour, so I'm just going to follow the green here. If he picks green the first time, how many greens would he have for the second time? Well, because they said he took 2 pens at random from the box, I don't think he replaced them, right? I don't think he put it back. So, therefore, in terms of how many green pens there are, that would be x minus 1, which I guess is kind of links to your n minus 1 logic. And then out of that, there would also be 1 pen less or fewer in the box generally, wouldn't there? So do you see how that would have to be 2x plus 2, not 2x plus 3? And then same with the blue. If we've already picked 1 blue, do you see how then there would be 1 less blue out of also 1 less pen in the box? Then I highlight my options that are relevant. Obviously, I've only filled in the ones that are relevant. So it could be that he either picked both green or that he picked both blue. So that's why I didn't fill out the middle ones, because we don't really need those, do we? Now, with a tree, you multiply between the branches. So now I'm just going to set up the equation. So that would be for green, for both greens, you'd obviously multiply these together, right? And then, for both blues, same thing, multiply them together. Now, when you see how we've got 2 options here, it's either both green or both blue. When it's either or, when you've got multiple options from our tree, that's when you add them. So see how I would add those? And then, let me move it over a bit actually. My answer to this, so obviously I need to create an equation, don't I? My answer, that equals the 27 over 55. Oh, that's a line. I'm going to move it over a bit so it's not in the corner there. Just keep moving it over. See if we've got room. There. So that equals 27 over 55. Okay, and then you've just got an equation from there. Right, that's all you need to do is then solve this equation, which I think I went through this. Yeah, I went through this in one of my videos, so I can link the video that you can have a look through. I'm just conscious of time, that's all. Kind of my only reason. I can link the video in the description so you can have a look at that. So I'm gonna probably whiz through expanding this, because I think I went through this in one of the other videos as well, like one of the other lives as well, but anyway, you should get x squared minus x. Now they have the same denominator, right, so I can add the other one straight away. X squared plus 5x plus 6 over, and if I expand the denominator, 4x squared plus 4 plus 10, yeah, that would make 10, wouldn't it? Plus 6 is equal to 27 over 55. And then you simplify it, you end up getting a quadratic, right? So that's 2x squared plus 4x plus 6. What I did before I started cross multiplying is I just simplified the fraction. Do you see how all of these can be divisible by 2? I just made that a bit easier. I don't know if you're mostly asking about the initial bit, the probability bit, because at this point this is just equations, right? This isn't even probability anymore. Oh, okay. We've lost it. Anyway, so yeah, you would just solve that. Now, because it was a quadratic, let me get it back. You will get 2 answers, right? You will get 2 answers. So I'll just quickly tell you, because you have to choose between the answers. One of the answers, you know how they mentioned at the top? We haven't used this information yet, have we? The 12 pens in a box. When you get your solutions for x, just double check which one. Do you see how we said the total was 2x plus 3? Sub them both in. Only one of them will give you an answer bigger than 12. So then you would choose that one. But I think I'm assuming the question was more so about the probability tree, like how I got the -1 and stuff. I'm assuming that's kind of more what you were asking about. But yeah, I can link down below the video if you want to go through it step by step, just because we are running out of time today. But I don't know if that at least kind of roughly answers your question, at least in the first bit. I think if I'm not wrong, I think the answer was 21, but I think it was either 4 or 21. You had to choose 21, the bigger one, basically. I think that was the answer from your quadratic. If you do find the actual question that you were wondering about, then you can come back to another live and we can go through that actual specific question as well. That's fine. Okay, we can go through the congruent question really quickly, but I will have to finish before 6. Okay, guys. So if you have that, yeah, if you have that congruent one, we can do that really quickly. If not, I will do another one tomorrow, another Q&A at 5 o'clock tomorrow. The actual past paper questions, past paper run through will be at 7. So we can also do tomorrow. But yeah, if you have it ready, which one is it? We can quickly look at that and then we'll finish there. Let me just get that the actual video for you whilst you're finding that question. Pretty sure it was in this one. Yeah. I think it literally uploaded last week, this video, or the week before. There's the link if you want to have a look through some harder. Some of them are quite similar, so it might, include the one you're looking for. Okay, you said Corbett Maths question 21 congruent triangle. Is that just generally maths? Corbett Maths. Keeps telling me I'm late. GCSE revision. List it's in. Was it in like an Edexcel list? I used to have just a normal, yeah. Oh, videos and there we go. Congruent triangles. Congruent triangles. Practice questions or the textbook exercise? Because they've got 2 options here. I'll see which one has question 21, I guess. Is it the one that's, what is that? An octagon? And it's got like loads of things overlapping. Is it that one? This one? Yeah. Yeah, that looks awful. Okay, so congruent triangles, you have to prove they're identical, right? So what we're trying to prove is that you've got side angle side, angle side angle, side side, one of those. It has to be like, you have to show that 3 things within the triangle are the same, not 3 angles. It's as long as you've got a side in there, I think it's fine. So which ones have they said? FHM, F to, I can't even see which one it is. Triangles F to H to M. Well, I guess we have to draw that in then. They haven't drawn that, so that's great. I don't think you get something as hard as this by the looks of it, though. That's the other thing. D, F, P. Where's that? D, F, P. Oh, yeah. Okay. And they've got a regular octagon. DN and FM are perpendicular. Where's that? FM and DN are perpendicular. All right. There. Yeah, this was a lot, isn't it? I would assume you'd probably use the same. We just did an octagon, didn't we? When we worked out the angles, you could use that same formula if you actually wanted to work out some angles. I mean, immediately. Oh no, because that's not in the triangles. I'm looking at the other thing. That triangle, and then it's hard. You can barely even see which triangles they're looking at. D, F, P, that one, and then that one. Awful. I mean, I know that FH and FD are the same lengths. That's a side, isn't it? How would we show that? Could you just say for the reason that it's a regular octagon, or would you need more detail than that? That's the bit that I'm not sure. I mean, I don't think this is accurate to what they'd ask you in Edexcel. That's the only thing about Corbett Maths is obviously they're great practice questions, but they're not necessarily super representative of what you would get. I think if anything, Maths Genie is a little bit more similar to Edexcel out of the two. And first class maths is quite good as well, but Corbett Maths is normally a bit random, I think. I think this is longer than the 2 minutes I have to explain it. No, we can go through it, but I think it's better if I do it in another session because I don't think I have time to get through it in like the 2 minutes because I have to be done by 6. So I don't know if you want whichever other live Q&A that you're able to come to, I can prepare it for then. I have got one tomorrow at 5 or between 5 and 7 basically. We could do it then or another time. We can go through it in more detail. But yeah, I don't think they would have something as hard as this on Edexcel. If you wanted, I've got actual Edexcel past paper questions on congruent triangles. We could also look at those so you could see what it would look like. I have seen it inside circle theorems before, so that might be somewhat similar. But yeah, we can always, whenever I see you in the next live, we can go through this with more time. Yeah, just because if you've got any questions, I want to make sure I've not half explained it. Yeah. But yeah, guys, I have to finish there for today, though. So thanks for coming. If you have any more questions, we're going to do another one tomorrow, somewhere between 5 and 7 o'clock. Tomorrow at 7 o'clock will be a past paper. Yeah, tomorrow Monday. Yeah. I think it's bank holiday, actually, but yeah, so we'll go through a past paper tomorrow at 7 o'clock, but we can do a Q&A at between 5 and 7-ish anyway. So if you've got any other questions, feel free to keep coming. So yeah, otherwise, hopefully we got through a fair amount of questions today, and thanks for coming. I'm going to leave the live here.